So let's move forward with installation, and of course before doing so we'll just have a quick look at the architecture to be sure that we understand where we'll provision the software du jour. So let's take a look in our documents folder. We should have a PNG that represents the topography, and that's this PNG. It should reflect what we're accustomed to, but we'll just point out any changes we've made. So let's just stretch this out just a little bit. This is our core network architecture. Usually does not change. It's largely intact. But what we have done is added a segment, and that segment is all virtualized, and it'll have as a default router pF1, which will be the node that will define running pFsense. It'll have two NICs, two interfaces, and on the subnet that it governs, it'll have three nodes: Linux CBT's ubuserves 1, as well as, or Linux CBT ubuserv 1, Linux CBT Win2 Windows, and Unix CBT BSD1. So BSD Windows and Ubuntu Linux. These are borrowed nodes from our standard subnet, so their names are duplicated, such as follows, but they're currently residing in this pfnet1 that we'll define momentarily. And it can be labeled with any IP address so long as the external interface of pf1 has an address that's on the core subnet of 192.168.75. So to effect that, what we'll do is use the addresses 3 and 4 for our PF firewall instances. Note that our Cisco firewalls have addresses 1 and 2. They are redundant. We normally route traffic through 1, and if 1 fails, 2 picks up the phone. So our PF firewall's external interface, this WAN interface, will belong to the 192.168.75.0/24 subnet, and as a consequence should have an address on it. So it'll have .3, and as we implement other PF instances, .4, and so on. So 192.168.75.3, and the default internal subnet that's allocated by pFsense is 192.168.1.0/24. So the nodes will belong to that subnet, 192.168.1.0, and that can be changed as needed. So that's our default architecture. Let's close that out, and let's continue with our study. So we need to download pFsense to provision it on our instance. The ISO image that's available functions or serves as a live CD, so it can be used to boot and acclimate to the firewall. So let's call this section installation. And our first task will be to download the 32-bit version of pFsense. Again, for your prod platform, if 64-bit is considered appropriate, then by all means, pull that version in and deploy accordingly. So let's see what we've got going on here. Let's take a look at the download link. There's a link off of here. And these are live CDs as well as embedded images that are located on these mirrors. So find a mirror that's closest to you, obviously. Currently no Vmware appliances are available. There are also upgrade files. So you simply denote your architecture. For us, 32-bit. We're not handling too many connections, so we don't need to exceed 4 gigs of memory. We'll perhaps just provision a gig of memory. That's sufficient for all our connections, and for many connections for many production environments, hosting potentially thousands of users for that matter. So the live CD with the installer is an ISO image that works for VMware installations, as it is a live CD as well as an installer. If your system boots from USB memstick, use this. And if you're embedding to, let's say, a CF or a compact flash card, this is the Nano BSD form. So we'll go with live CD with installer. And here are some mirrors that are available now. Currently, we're on the East Coast of the United States. So for us, NYI.net should be the closest mirror from which to pull. The link you see below is pFsense 2.1.4 release i386.iso.gc. Perhaps by the time you're using this edition of Unix CBT, a newer version is available, so just follow the latest link and pull it accordingly. The file's compressed, as you can see with the name of the file in the status bar that it has GZ, so it'll need to be decompressed, so it's 78, almost 79 megs. It'll extract out to about double the size. So download, file is gzip compressed. So decompress it as necessary. Within macOS, since we're using that, you just double click on the file and that'll decompress it accordingly. If we show this in Finder, it should locate its position within the tree, and if you double click, it'll simply extract the GZ to an ISO file, which is about double the size, at which point we can discard of the original file and then place this file on our virtual server, which is 192.168.75.100. Now, we should already have a copy of the file there, but normally under normal circumstances, you just SCP the file to your server. So as an example, SCP, and of course you'll need to have the appropriate privileges on your VMware instance, but our downloads instance and the pFsense file over to, say, one of our virtual servers, 75.100, which has space to host this instance. So this will copy it there once we've authenticated, and we can then move it into the appropriate repository once there. So let's SSH as root over to that node 75.100. And this should put us in. Let's see what we've got here. It says no space left on the device, so we are actually out of space. Let's see how much of the data have been copied. Actually, just a fraction. Well, let's remove RF, the pFsense instance that's there. There isn't additional space. We've already provisioned a copy in the appropriate storage. In fact, that's going to be VMFS data store. So LSL, VMFS, data store, volumes, data store. We can just place it directly into this directory here, and that should have space. So let's update this to be VMFS, data store, volumes, data store, and this directory is actually data store 1. And we'll place it directly into OS ISO images. This is a distinct volume. This should have enough space to accommodate the entire ISO image. That looks more like it. Now let's SSH back into it. The root file system didn't have the storage, so let's navigate into VMFS, that is, data store, OS ISO images, and we should see a copy of it. So we typically make directories for various operating systems, so it's clear what belongs where. So we'll just make a directory calling it pFsense. And then we'll move pFsense live image into pFsense. Let's see what it's doing here. It moved the file name incorrectly. Let's fix that. I'll take the original name. We've omitted the E in the pFsense directory, so we'll just move this pFsense back to that, and then move that into pFsense. And that should be fine. And now, from the perspective of the GUI, we should see this ISO image for 214. So whatever version you're running, that'll be reflected here, but it's the same process. If you have a virtual instance of a hypervisor as we do, just place it in a repository that's accessible to the manager of that hypervisor, and then you should be able to install. And you can use any hypervisor that supports BSD for obvious reasons. So let's move to trash the original file. This is no longer necessary. Clean up our footprint here. And now we're ready to set up a VMware profile to host this item. So download, copy to VMware server, perhaps using SCP with whatever specs are applicable. And then the next step for us is to configure or provision a VMware profile to host ISO image. Now this applies even if you're using just the live CD. So it applies to both live CD and installation. So regardless of your entry point, you'll want to provision a VMware profile that's set for FreeBSD. So some of the specs that are important for this installation include that it is virtual machine version 8. For our instance, of VMware, which supports through version 8. If you're running a later version of VMware ESXi, then you have up to 10, but we're going with the latest for our version, which is version 8. And that we select FreeBSD 32-bit as this is the platform we elected to download. And we'll dedicate one core, one socket, as this is more than sufficient for thousands of simultaneous connections. And similarly, 1 gigabyte of memory. And in terms of storage, 8 gigabytes more than suffices. So this will be, or these are the specs for the virtual instance that we'll define over on that server. So to set that up, let's navigate to that server. This is our Win Manager, currently locked. And this is our vSphere client. This will have us log in momentarily. This should bring up an instance. And we can create our new instance once it's up. No graphics are necessary to set up or manage pFsense. So here are all of our instances. This is an instance for our intents and purposes. And we'll define a new instance. So a new virtual machine. We can make it a custom virtual machine. We'll give it a name. So we've got UCBT pFsense 1. That should suffice. We'll use the default data store, which has 400, almost 500 gigabytes free. If you're running a later version, then pick the latest version available. And it's neither of those, but one of these, FreeBSD 32-bit. If you've downloaded a 64-bit version, go with that version. Default sockets, cores per socket, 1. Default amount of memory is a gig. And of course, we'll need 2 NICs. So this VMware server has 2 networks, VM Network 2, VM Network regular default. So how will these be allocated? When the operating system boots, the first NIC will be registered as EM0. The second NIC will be registered as EM1. So EM0 will be considered our WAN interface, and EM1 our LAN interface. That we should always remember because the VM network, the base network, is connected to the 192.168.75 subnet, which for this particular firewall is considered the WAN. VM network 2 will be that new subnet that's defined as 192.168.1.0/24. So EM0 correlates to the first NIC, EM1 to the second NIC. EM0 will be the WAN, EM1 will be the LAN interface. LSI logic is the default. That works for BSD. We'll create a new virtual disk. Its default size will be 8 gigs. We can do a thin provision or a thick provision, either or. Greater performance if we go with thick provision, but it uses the space up front, as is typically the case. Now we want to edit the virtual machine to have it boot from the ISO image before starting up, so we'll tell it to continue and then modify the properties of the CD-ROM that's associated with this node by pointing to the data store ISO file that is the pFsense image, which is located in OS ISO images, pFsense, and the latest version, whatever that happens to be. Ensure that it's connected at power on, so that when you power on the system, it boots up, and then we finish. And that's it. Now this node's available. This can be replicated to a separate node. If you take a snapshot, you can always revert accordingly. That's usually a good idea. Or you can take a snapshot after the firewall has been set up, after you've provisioned the configuration options. Either or, just make sure that you get these settings right once the firewall has been installed. Freeze it in the event that you need to replicate the configuration. Now when we power this on, it'll prompt us with some questions to configure the firewall in live CD mode. So let's power it on, navigate to the console, and this should fire up some useful information momentarily. Let's get rid of this navigation bar just to free some space. We can also get rid of the additional toolbar. It gives us additional space. So the default is the boot pFsense. All installation to the file system takes place from a booted live CD installation or live ISO image installation. So this is the default means for bringing pFsense up. Just have it boot. And if you decide to go with pFsense on a longer term, then install from the menu that's presented post boot. So this boot will load common drivers for common interfaces and try to determine what's there and help us set up a sample firewall. So here we see some options: recovery mode, I for the installer, and C continues with the live CD boot up mode. So at this point you could install directly without having done a live CD test, or you can have it boot and do a live CD test and see how the firewall behaves. If you are using VLANs, there's an opportunity here to configure interfaces for VLAN support. Notice our two detected interfaces. Let's just Control-Alt to pop off EM0 and 1. 0 is the WAN, 1's the LAN. Let's tell it no for VLANs. We'll omit VLANs altogether. And let's move on. So enter the WAN interface. You can have it auto-detect, or we'll just tell it explicitly that it's EM0, the external interface. That's the WAN interface. Now this asks us for the LAN interface, and we'll tell it that it's EM1, or A for auto-detection, which would detect the lone remaining unassigned interface. It tells you also that it enables firewalling in NAT mode, which means in addition to routing, it performs firewalling in NAT. So it'll set up a subnet on that LAN interface of 192.168.1.1 to allow basic, or 192.168.1.0/24 with an address of 1.1 to allow basic communications out of a subnet, as a standard appliance such as Linksys or otherwise would. Now this optional 1 interface is tantamount to a DMZ interface. If there's a tertiary interface, you can designate it here. Otherwise, you can tell it that there's none by pressing enter. So then it reiterates the interfaces that have been assigned. The WAN is EM0, the LAN is EM1. Those are your two interfaces. We'll tell it to proceed with configuration. Remember that these settings that are being written are not permanent. They're only persistent for this boot of the operating system, for none other, unless you write the settings to the file system, which effectively installs pFsense within the virtual instance. Now when pFsense comes up, this is the menu that's presented. It includes release information. It includes the fact that it's listening on the serial port, the first serial port, COM1. It always enumerates the interfaces under its auspices, including their roles, whether WAN, LAN, or optional 1 or optional N, optional 1 through optional N. You'll also see that unless you assign otherwise, as we've already reiterated, that the LAN interface defaults to 192.168.1.0/24 with a default address of .1. The external address is configured using DHCP by default. So though we intend to use a .3 address, it defaults to DHCP. It picks up an address. As it currently stands, if we connect a client to the LAN interface, any of these clients, we have a few that we want to provision, as we've already mentioned, such as Linux CBT ubluserv1, they'll automatically obtain an address from the DHCP server running on the firewall as expected. A number of options are included, such as assigning interfaces, setting interface IP addresses, resetting the web configurator password from the default pFsense, and other options such as the ability to reboot the system ping, so on and so forth. You can test communications really quickly just to see whether or not you can talk to other nodes on the wire by trying to ping, let's say, something that you know that exists, such as the default gateway on the wire 75.1. That should return some packets indicating that all's well. Now, without any passwords, we're able to halt, reboot, and interact with fully this live CD implementation. So it's not secure. So this isn't a way for you to implement a production pFsense instance for obvious reasons. There is a shell which gives you access to the BSD underlying operating system. There are logs such as pftop and so on. So right now the firewall is up and running. It's hard to tell that it's hard to believe perhaps that it's set up so quickly. It's incredible that we have such quick access to it. But it indeed is up. We can scan it to see what's available, let's say from another system. And so we pop back over just to see what appears. We know that's 7577, so let's jump back over to our Mac instance. And let's find a node that has perhaps Nmap. Let's see if we've got it here. We'll SSH over to 75101, And from here, try to interrogate that node to see if it responds. Let's do an nmap 192.75.77. Now, what this will tell us is that it doesn't believe there's anything running on 75.77. This is because by default, the interface doesn't respond to pings coming in off of RFC 1918 addresses or bogan networks that should not be routed on a WAN, a quote-unquote WAN or WAN in inverted commas. And that's because, again, the assumption is you've plugged or connected pFsense into a true internet connection. So the profile's up. We've booted as a live CD. Let's just pop that in. Boot as live CD mode. Examine defaults. Now that we've examined defaults, let's say we try to ascertain data from pFsense instance by using, for example, nmap. So we nmap the address that's presented 75.77. And let's just note, nothing is returned by default because pFsense does not respond to bogan or RFC 1918 addresses on its WAN interface. And this is by default. So that's why we're not able to ping it, and there are no open ports by default. Nothing's configured. Firewall is there. If you did send some packets using normal ping, again, it's configured not to respond, so you get no response, but it is there. And the reason why we know it's there is because from the perspective of the firewall, we're able to communicate outbound. So we can send packets to, say, 75.1, and those packets come back, the ICMP packets. So the firewall is present. It is using the address. It did obtain it from a DHCP server on the 192.168.75 subnet, but it's configured in a secure mode to not permit traffic coming in from nodes that are considered to be RFC 1918 or bogan networks or networks that should not be routed on the internet. So you should get no information coming back, but if you scan from the internal side, you should get some information coming back from the default gateway. In order for that to work, you'll have to boot a node up and have it connect to the network. So for example, let's pop back over to one of our nodes. We did say ubuserve1 should be on that subnet. So let's find that node. That's going to be here. Let's fire it up, power it on. The console should come up momentarily with its interface. And if it has a GUI, we can just default to the shell to send some packets over. But this should DHCP client request an address from the pFsense instance running on the same subnet. We've already pre-assigned the subnet such that the nodes that we've mentioned are automatically a part of the same subnet. And this will just check the disks quickly, and this gives us a GUI interface, but we can try to pop on over to one of the default consoles to see if it'll allow us to do so. Let's see what we got going here. Let's try to click in, and this kind of pops off. And that gives us an interface. Now let's see what we've got. So there we see 1.102 as an address, and we can confirm that with ifconfig and then grep out the inet. But there's 102, so obviously that comes from the DHCP server. Let's cat etc resolve conf to see what it's gotten. So it's configured with 1.1 with a default search local domain. So that tells us a little bit about Firewall, that it's configured to serve out local domain as a domain, a searchable domain, and that it uses itself as a DNS server. So it must be running some sort of DNS service such as DNS mask to provide forwarding of DNS requests. So that means if we do a dig, for example, linuxcbt.com, this should come back with something. 1.1 fulfills the requests by forwarding the requests upstream. So DNS is automatically configured as you would expect, and it caches the results as we would expect, just like a standard off-the-shelf firewall router solution such as Linksys, D-Link, and otherwise provide. So we're up and running. Now what about sending packets out, ICMP? Suppose we try to send 3 packets to the default upstream gateway. Well, first let's try to ping the default gateway 1.1. We expect that to respond because it's the same subnet, the same internal subnet. Now what about outside 75.1, which is considered to be the WAN interface? That's permitted because internal nodes are allowed to send traffic through the firewall, and because it's stateful, the correlated ICMP echo responses are returned through the firewall. So we can send packets out. We can also send packets, let's say, to 101, the same node from which we tried the nmap, which didn't work. So let's try to do an nmap of maybe 75.101, and there we can see the open ports available. So we know we're on the wire, and that nmap initiated the query on the 75 subnet as 7577, which is the pFsense external interfaces address, EM0's address. So that certainly works as well. 75.1, 75.101, everything's coming back. We should be able to connect out to the net. So let's say we try to nmap maybe dev1.linuxcbt.com. This will then forward it upstream to the net and figure out which ports are available, SSH, 80, and so on. So that looks good. It's coming back as we expected. It believes that there's some Windows ports, but they're none. It's just 22 and 80 that are running on those nodes. So we certainly have external connectivity, as we can tell, and one address has been assigned. Now let's pop back over to this vantage point. So we know we're giving out addresses. We know that this is looking good. So what's left for us to do? Well, let's pop back over yet again. Actually, before we do, let's just take a note. So try to ascertain data from pFsense instance, nmap 7577, nothing comes back. From perspective of node on the 192.168.1.0/24 subnet, try the same, and that works. So B1, all queries work because pFsense auto allows stateful connections using common protocols. So ICMP, TCP, and so on, UDP, etc. And this should be state full, not stage full. That looks more like it. It'll throw an error because it wants a hyphen, but that's besides here. Now let's pop back over just to see if there are any other data, because again, we're pretending we're in sampling or testing mode of this firewall. So let's see what's happening on the console. So we know there are some other options from the console. Let's say we wanted to see the top traffic flowing through the firewall. And there we should see the traffic flowing through. So 1.102 has made the following requests outbound. And those are the top flows flowing through. We see some IPv6 traffic, IPv6, ICMP v4 off to 75.1, and it includes the size in bytes as well as the number of packets sent and so on. You can normally quit the submenus with Q, and if that fails, try Control-C. Either or should get you out. There are filter logs. This is a TCP dump of the traffic that's flowing across the interface. So currently no traffic's flowing. Usually this screen requires a Control-C to escape. If you generate traffic from one of the other nodes, you should see something coming through. Every now and again, you'll of course get broadcast traffic. So there we see some broadcast data, 7598, port 138, or 7595, port 138 coming back to the broadcast address. That's broadcast traffic. From ubserv1, we can generate some traffic using nmap back to, say, dev1.linuxcbt.com, and then pop back over to use CBT pFsense 1, and that should pick up some traffic heading off to that node as well, and that'll pop up momentarily. Actually, it's already there. Traffic showing to 188.40.55.66. Port 80, it picked up that packet. If we're done with this dump, Control-C, that's the pf filter logs interface. If for some reason the web configurator is inaccessible, option 11 will restart it. There's a developer shell. You can upgrade directly from the console with option 13. You can enable secure shell. So what does that mean? Well, from the perspective of an internal node, use CBT serve 1. Let's say we try to nmap 1.1 and see what ports come back. So let's see if by default it picks up SSH. It's got SSL, port 80, and 53 for domain, but no SSH. That means we can't SSH into the service. And what happens if we do SSH into the service? Well, let's pop back over here. Let's enable SSH, and that's obviously going to turn on that service. So 14, option 14 will fire that up. And again, none of the settings here are saved unless you write to the file system. If you reboot, you've lost all your settings, but we'll see that momentarily. Now let's pop back over to ubuserve1, re-execute that nmap. Now we'll see SSH is open, which means we can connect to the service using SSH from any of the internal nodes. So let's SSH into 192.168.1.1. And this is saying that it's a different key. And what we need to do is remove the one that's there. So let's SSH keygen from, well, actually it's a default. So we want to get rid of 168.1.1. That's a default file. Let's try it again. That should just pick up the default file. And let's try it again. Let's try to SSH back into it. It should prompt us for a password. The default password is pFsense. And that pops us in. So when you SSH in without specifying the user admin, which is the default, you're presented with the same interface that you see on the console. And that's this, with the option to reboot, halt, so on and so forth. Or even to kick yourself off by defaulting to disabling SSH. So you can now make changes from SSH across the wire if necessary, which may be if you just want to test how things work. And you see optionally, option number 99 to install to the hard drive. We'll hold on for a moment and try to do some default things. So let's say we change an IP address of the default listener to 75.3 on the external interface, the WAN interface. That's just setting the interface IP address. So 2, and this is going to change the WAN interface so it won't impact our SSH connection. So it asks us if it should use DHCP. We say no, then it prompts us for an IPv4 address. Ensure that the address is a free address that's not in use by anyone else. Specify the number of bits that apply, 24 bits, and also specify the upstream default gateway so it knows to where to route traffic. And if IPv6 is enabled on the external interface, enable it here. Otherwise, tell it none. And this will disable DHCP on the external interface and then set a hardwired IP address. And it will tell it to use HTTP for the web configurator. And that'll make it accessible as well. And now it becomes accessible on 75.3 as well as the internal address. So now we're 75.3. So any packets outbound should reflect as 75.3. And of course, TCP dump can confirm that. If we try to ping something, let's say we send some packets off to 75.101, it should still come back. And on 101, if we do a TCP dump, just ICMP, we should see that the packets come in as 75.3 as opposed to 75.77 because the address has now been changed. So again, any of these settings you affect will be lost. Supposing we reboot the system, well, we'll lose all routing capabilities. So let's reboot. And we'll tell it to proceed. And once that reboots, if we return to the console of the firewall itself, we should see it rebooting. And then from the perspective of ubuserve1 now, any external requests should fail. So say we try to do a dig, that's an nmap, or even an nmap of 75.101. We have no means with which to route outbound to that system. Similarly, a dig, let's say if www.linuxtv.com fails because the firewall currently isn't running. Let's go back to CBT pFsense 1. And this should be at the main menu. It's going to come back up with default settings using DHCP to obtain an address which should serve at 77. As the most recent user address, DHCP tends to reserve or reallocate the addresses in a consistent fashion. So it's bringing the interfaces up. It'll be back to DHCP and so on. And it asks us how we'd like to use the system. C continues with live booting. No VLANs. WAN interface is EM0. LAN is EM1. There is no optional interface. And again, these settings are all being rewritten on the fly. And once up, the internal node will be able to communicate outbound. but under the new address of 7577. So settings aren't changed. So back to ubuserv 1, that internal node for a moment. So now if we kick off a dig, it works again, going out as 7577. And if we do an nmap, similarly, it works again as 7577. So that raises the question, how do we commit the configuration? We just write to the file system, and that does so. So option 99 takes care of that. This will write it to the file system and take us through the setup. So it knows that it's running VMware. It's going to check it just to make sure it looks good. And we'll tell it to accept these settings. We just want a basic console with a quick and easy install, automatically without asking any questions. And this will install without the static address of 75.3, but we'll change that after, and that'll be written accordingly. Now this will perform a quick installation of BSD to the file system within that container for UCBT pFsense 1, such that subsequent boots will no longer require the ISO image, and will bring the firewall up with a gig of memory, 8 gigs of storage, and with the configuration for pF set to what we have designated. And then subsequent changes will be written to the file system and will often require reboot to confirm persistence. So embedded kernel, no VGA console. We want the standard kernel because we do have a VGA console, so we want to see things both on COM1 if necessary, if COM1's available, and on the plain console provided by VMware. So it tells us at this stage we can disconnect the ISO image. That's rather straightforward. You can reboot. You can shut the system down if you want. You can wait for it to get to the main menu, shut it, disconnect the CD-ROM, either or, just to be sure it's not booting from the CD-ROM or the ISO image that represents the CD-ROM. And as you can see, it runs lig-httpd. That's not a surprise. Typically, these embedded systems run lig. Here we have the option to boot the system. It's going to boot automatically anyway if we do nothing or interact with commands. We can elect to shut the system off, so power off. That'll kick it off momentarily. Then we can edit the settings associated and ensure that the ISO image is not connected at power on. Then fire the system up and ensure that it's able to boot, albeit with a DHCP external address, which is what's normal for connecting to external LANs. Notice it boots. If we F1 at the stage, it'll boot. If we wait, it'll boot. Either or, it'll boot at some point, so we'll just give it a little time. And momentarily, we should see that it's ready to boot into pFsense. 1 second go. You can modify it so it requires less time, so it doesn't prompt. This will come up, detect the interfaces, DHCPD external, set the internal to 192.168.1.1, so WAN and LAN respectively. And that will check the disk. It knows it's VMware. It knows it's within a virtualized environment. But that's fine. So long as the resources are available, it'll work. CFS, init, etc. Another feature we didn't mention that's supported by pFsense is traffic shaping. So you can QoS traffic if necessary. So there we see the DHCP on the external. And if you want to set this to something static, such as 75.3, modify that interface. It's supporting DHCP, DHCP 6. We'll tell it no DHCP. Use this address, 75.3, with 24 bits. For the LAN interface, or for the WAN interface, I'm going to do a WAN IPv4 upstream gateway 75.1. IPv6, we'll tell it no for now. That disables IPv4 DHCP on that interface. And we'll have web configurator listen on 75.3. And momentarily, we should see the new configuration. So now it's 75.3. To confirm this all works, reboot the system. You can always reset the factory defaults. That's like resetting your router, whereby when the system reboots, it asks you questions concerning the configuration to rewrite the entire configuration if necessary. Sometimes you clobber the configuration. The rules become so convoluted, you just need a quick way out. That's the way out. You reset the factory defaults. But before doing so, let's just reboot to be sure the system comes up with 75.3 and 192.168.1.1 as a subnet. We have no problems with 192.168.1.1. We're not using that subnet elsewhere on our network. So for our intents and purposes, that works just well. All of these activities, by the way, are logged. There's a comprehensive logging system, as is the case with production commercial firewalls. So if you make a change, you add or subtract or modify firewall rules, everything's logged. So you should be able to see who did it, when they did it. The auditing trail is pretty comprehensive. So this should come out momentarily, just offering a few seconds to boot the system. 210 goes. Has a typical ACPI, use a USB. Again, it is FreeBSD under the hood, so it is essentially a PC, if you will. As routers are, by the way, firewalls are. Let's see what happens as this comes up. It should come up with 75.3. And again, pretending we've clobbered all the settings, when it comes up, you can decide you want to reset to factory settings and rewrite the configuration altogether. So we'll wait this to come up. Before doing so, we'll just make sure we can actually route traffic through it. See the services starting, NTP, web configurator, DHCP, v6, so on. So there's 75.3. And then from ubuserv 1, let's see what we've got going on here. We've got a console if it's responding. Sometimes the console doesn't respond. We have to kind of navigate away, come back. Let's go to use CBT pFsense 1, then come back to here, then back to here. And that usually causes it to reread the console. If it doesn't, we'll navigate away, have it display something else. Try again. And nothing here. And again, the router is currently not set up to allow traffic from the external, especially the RFC 1918 addresses. It just won't do it, so we won't be able to connect remotely. So we have to be able to connect to the console, whether it's via COM port or otherwise. So we should still have an address. Nets.rn should show the default gateway, send some packets to it, 1.1, and then let's rerun our nmaps from earlier, let's say of 75.101, and that should send traffic through the firewall. And let's see if it comes back 75.1. If it doesn't, sometimes you'll have to obtain your DHCP lease, because this lease is from the recent implementation. So let's say actually it discovered the open ports, it found some stuff. So it is routing traffic through. In fact, let's try to send some packets just to be sure outside of the convoluted nmap to 75.101. And that means traffic's flowing. 75.1, linuxcbt.com. DNS is not working. So let's do a dig, linuxcbt.com. And it's not coming back. Sometimes this happens. This can be an issue. We've seen this a couple times with pFsense. So you may have to configure the DNS to use something else. For example, if you do a dig at 75.1 linuxcbt.com, it'll come back with an address. So sometimes the DNS mask service doesn't work. Sometimes you'll have to restart that service. But back to UCBT, and that can be done through the web GUI. By the way, we're doing more from the shell than you typically would with pFsense, because our natural tendency is to use the shell. So we're at 75.3. If for some reason you think there's a big problem, you've convoluted your settings, reset to factory defaults using the number option of 4. So this resets the factory default. And again, all of this can be done haphazardly without any authentication. So that's yet another option we'll enable once we start using the GUI to ensure that outsiders don't have access to the pFsense firewall. The default enables access to anyone who has access to the serial port or the VGA console. So that's not a good thing. Let's have this boot. This is going to come up anew. Have it boot, just expedite it there. And it'll prompt us with the questions again to rewrite the full configuration. Configuration is spelled out in a file. You can access the file from the file system. It's not suggested that you do, because pFsense is written in a way that it's driven through its menus, largely through its web configuration. So although you may access the underlying config files, it isn't suggested. But if you do need to customize it beyond what's permissible via web configurator, then by all means. So no VLANs. It's detected the two interfaces. The external interface is EM0. Firewall NAT mode. EM1 is going to be the LAN interface. No optional interfaces. Let's proceed. Writes the configuration. It'll use the DHCP. Chances are at this stage, if we perform a dig from the client perspective, it'll work. So there could be a bug when alternating between DHCP and static configurations. Let's take a look at ubuserv 1. Let's see if this will read the console for us. And nothing just yet. Let's pull up another screen and try to reread the console. And still nothing yet. As we've mentioned, sometimes it's a little tricky. Console doesn't always automatically come back up. Sometimes you have to wait just a little bit, but let's go back to Serve 1, see if it pulls it up here. Nothing there. And again, we're at a stage where we have to access the console, so there's really no choice. Back to Serve 1, back to console. Now it's coming up. So let's try that dig again. Let's click in. And notice it works this time against the default 192.168.1.1. Now when we alternate between static or between dynamic and static, we might lose that DNS capability, which can be fixed later on. So let's set the address yet again of that external interface. That's going to be interface WAN, and it's going to have no DHCP, and it's going to have an address of 75.3, 24 bits, with 75.1 as the upstream. IPv6 not necessary. And that should restart services and give us the new settings. Web configurator 75.3. And let's continue this. There's our main menu. So now it should be 75.3. Packets should still pass. Let's go back to Serve 1. And every time we do this, we run the risk of not getting the console. The dig is working in this case, so it's just a fluke in that particular example, but sometimes it does fall off. That's a DNS mask service. If you see the inability to perform queries through your pFsense, restart DNS mask. That usually fixes the issues, and also check your forwarder's configuration. So we're using 102, that's the current lease, and we should be able to nmap v maybe dev1 like cbt.com, see what comes up. That should send some packets through. Let's see if it does it. Nothing coming back. It's not resolving it. Chances are, let's do a dig dev1 like cbt.com. It is resolving it, so it's not connecting to it, so we need to double check. It shows no ports. Let's try doing an nmap of an internal node. Say 75.101. See if that goes through. That goes through. So we're not routing upstream. And let's try to do dev1 yet again. 188, so it's not connecting. So let's see what's happening on our server. Unix CBT pFsense 1. And here's some messages, backwards, runtime, so on and so forth. 75.3, 1.1, assign interfaces. Well, the rest we'll fix through the GUI because that's where we expect to perform most of our work. So far so good, just a few issues, but nonetheless we're up. We can double check things from the web configurator environment. So next, let's start transitioning over to the main means of configuring pFsense, and that's from web configurator.